Okay, good morning, guys. We have our quiz tomorrow over factoring completely. So I just wanted to do a couple extra problems just to give you a little extra practice review type thing. So if we look at number one, factor completely, the first thing we're going to look for is a GCF. There is no GCF to take out, so I'm going to say, okay, I have three terms. Is this a trinomial? Is this a perfect square trinomial? Is the first term and the last term perfect squares? And no, they're not. So we're going to say, all right, well, this is probably just a trinomial where we're going to factor where a is not 1. All right, so we're going to take a times c. So I have 2 times negative 15. What are the factors of 2 times negative 15, which is negative 30, that will multiply to give me negative 30, but add to give me positive 7? So let's see, what can it be? I'm going to try with... I have x's in the front, y's in the back because I have x squared and y squared. But I'm going to go with positive 10 and negative 3. And since my a term is not 1, it's 2, I have to divide each of these by 2. So now I'm going to say, okay, does 10 divide by 2 nice and pretty? It absolutely does. So this binomial is going to be x plus 5y. And does negative 3 divide by 2 nice and pretty? No. So then this 2 is going to come out here and become our coefficient of the second binomial. So 2x minus 3y. And again, guys, you can always, whatever you get as your answer, you can always FOIL it back together, and you should end up with what you started with. All right, look at number 2. Same thing. I have 2 terms, so I have 3 terms. I'm sorry. See 1, 2, 3. I'm going to look for a GCF, and I notice that each one of these terms has an x in it. So I'm going to go ahead and divide out the x. I divide out all x's here. Remember, we did not do anything with the x other than just pull it out in front, so it does not disappear. So that leaves me with 4x squared plus 8xy minus 5y squared. So I'm left with a trinomial, and I say, is this a perfect square trinomial? Well, 4x squared is a perfect square. That would be 2x and 2x, but negative 5y is not. So this is going to be our traditional factoring where a is not 1, and it's a trinomial. So I have x, and then I'm going to put an x in the front and a y in the back, x in the front, y in the back of each binomial, and the reason why is because both of these are squared. Now I'm going to say 4 times negative 5 is negative 20. What are the factors of negative 20? That'll multiply to give me a negative 20, but add to give me 8. So that's going to be positive 10 and then negative 2. Negative 10, sorry, positive 10 and negative 2 is negative 20. Positive 10 minus 2 is going to give me positive 8. Good. So then I'm going to take my a term, which is 4, divide each by 4, and see what we come out with. So 10 divided by 4, that does not divide evenly, but it can reduce. So this is going to become 5 over 2. And then 2/4 could simplify to 1/2. So your binomial, you have x out in front, your binomial is going to become 2x plus 5y. And this one is going to become 2x minus y. Since the factors don't divide out evenly, your denominator just becomes the coefficient. And again, you can multiply out, and you should end up with what you started with. All right, if I look at number 3, GCF. No, there's not a GCF. So I say, I only have 2 terms here. Is this the difference of perfect squares? Well, difference means there's a minus sign in between 2 terms that are perfect squares. And that is absolutely the case. What times what is going to give me x to the 4th? X squared and x squared. What times what is going to give me negative 16y to the 4th? That's going to be 4y squared and 4y squared. So your 2 parentheses have an x squared in the front, a 4y squared at the back, and your signs are going to be 1 positive, 1 negative. Now at this point, guys, remember, we need to ask ourselves, can I simplify this anymore? Can you simplify x squared plus 4y squared? No, you cannot. That is not the difference of perfect squares. But can we simplify x squared minus 4y squared? And here you can. What times what's going to give you x squared? X and x. What times what's going to give you 4y squared? It's going to be 2y and 2y. So this binomial is another difference of perfect squares. So this is going to be x in the front, 2y at the back, and then a plus and a minus sign in the middle. So make sure, always, especially when you have 2 terms and a minus sign, guys, make sure you're thinking, could this be difference of squares? All right, next one. Excuse me. GCF. No. So I say, okay, I have a trinomial. Is this a perfect square trinomial? No. P squared is a perfect square, but negative 24 Q squared is not. So again, we're going to factor traditionally. I have A times C. So 1 times 24. What are the factors of negative 24 that'll multiply to give me negative 24, but add to give me a 2? So I know I'm going to have a P in the front of each parenthesis, and I'm going to have a Q at the back because I have P squared. I have a P squared here and a Q squared here. So my factors that I'm going to use are going to be a positive 6 and a negative 4. Because 6 times negative 4 is negative 24, and 6 minus 4 is going to give me, good, 2. So now I say, all right, do I have to do anything else? Do I have to break this down at all? Do I have to divide each term by anything? And in this case, I do not, because our A term is 1. My A term is that number right here in front of the first squared. So there's nothing else left to do. I just circle my answer and I'm good. And again, if you multiply that back, you would come out with this. All right, my last one. Again, I have 2 terms. So I'm like, ooh, is this difference perfect squares? No, because there's a plus sign. But is there a GCF? And I look right away and I say, yes, I can divide out a 3x from both of these. All right, so when I divide out my 3x comes out in front here. 81 divided by 3 is going to be 27. My x's will cancel, and I have y cubed. Plus 3 divided by 3 is 1. X to the 4th divided by x is going to leave me with x cubed. So now we say, okay, can I factor any more? I know this isn't the difference of anything, but do I have the perfect cube pattern? Let's look. What times what could give me 27? Well, that would be 3. What times what would give me y to the 3rd power? That would be y. And then what times what would give me x to the 3rd power? That would be x. So this actually is a perfect cube pattern. So I have my 3x out in front, and my perfect cube pattern, the first parenthesis is a, whatever the sign is, plus b. So it would be 3y plus x. And then my pattern inside is a squared minus ab plus b squared. So my a term is 3y. If I square that, that becomes 9y squared, because remember that 2 goes to 3 and to the y. I'm going to multiply these two together so that I have minus 3xy. And then I have plus x squared, because we square our b term. And then we can circle our answer and say we are done. So guys, remember, tomorrow is your quiz on factoring completely. We need to always ask ourselves first, is there a GCF? Then we're going to look, and if it's 2 terms and there's a minus sign, is it the difference of perfect squares? If it's a plus sign or a minus sign and something is raised to the 3rd power, it could be difference of, or plus or minus, some difference I should say, sorry, of cubes. 3 terms, we're going to factor a traditional way with factoring a trinomial. Factoring trinomials. And then remember, with 4 terms, what do we do with 4 terms? We're going to group. 4 terms is going to be, so 4 terms, we're going to group. And you guys might have to do a variety of things all in one problem. So if you have any questions, email me today.